Hello dear friends, good morning to everybody. Today let us see lecture number 4, chapter number 5, continuity and differentiability. In last 3 lectures, we talk on continuity. Today let us see differentiability to find out d by dx of some function. And we also noted standard forms in last lecture. In form of composite form, d by dx of sine of some function is equal to cos of some function into d by dx of some function. Let us use that standard forms and I try to solve the examples. Now see here. Find derivative of function given by f of x is equal to sine x squared. F of x is equal to sine x squared. Differentiate with respect to x. See, this line is necessary. Here we are differentiating with respect to x. D by dx of some function, that is fx. So d by dx of fx is equal to d by dx of sine of x squared. Sine of some function, cos of some function, d by dx of some function. And what is d by dx of some function? Right, last derivative first. Some function square, 2 times some function, d by dx of some function. Rest of part as it is cos x squared, but that comes out 1. So 2x into cos x squared. This is the derivative of sine x squared. Second part, what we want to see? Second part, f of x is equal to, what we want? Find derivative of tan of 2x plus 3. So, tan of 2x plus 3. So, differentiate with respect to x. So, d by dx of f of x is equal to d by dx of tan 2x plus 3. Tan of some function, sec square of some function into d by dx of some function. For derivative of 2x plus 3, 2 constant, derivative of x is 1. So write last derivative first. We can write this also, 2 into dx by dx plus 0 into sec squared 2x plus 3. Here, so ultimately it comes out 2. You can write directly also, derivative 2x plus 3 2 also. Sec squared 2x plus 3 is the answer. Third one, sine of cos of x squared. See here. Third part, f of x is equal to sine of cos of x squared. That is given to us. So first line, once again, differentiate with respect to x on both sides. So d by dx of fx is equal to d by dx of sine of cos of x squared. D by dx of sine of cos of x squared. Sine some function is cos x squared. That is cos of some function, d by dx of some function. Clear? So, cos some function minus sine function. So write minus sine first. This step as it is. Cos some function, sin some function, d by dx of some function. See, whenever only both variables are same here, so you can apply that standard form also. D by dx of some function square minus 2 times some function d by dx of some function cos of cos x square into sin x square. Very easy, but that comes out 1. So minus 2x cos of cos x square into sin x square. Is it clear? Yes. Next, let us see. Find derivative. Differentiate following functions with respect to x from 1 to 8. Now see, first one is the sine of some function, cos of some function. Cos of sine, first, second, third, and eighth one. Let us leave these four sums for you. Like a previous example. Let us see fourth one. We can suppose that is equal to fx also. Same way we can suppose that is equal to y also. Suppose y is equal to sec of tan of root x. Differentiate with respect to x. Differentiate with respect to x on both sides. What we get here? dy by dx is equal to d by dx of sec of tan of root x. There is no need to write all the such brackets. You can write in that way also. Now we know that, dear friends. What is d by dx of sec some function? Recall that form. Sec some function, tan some function, d by dx of some functions. Sorry. See, the right that is equal to sec some function, tan some function, d by dx of some function. Sec some function, tan some function, d by dx of some function. And that is equal to this as it is, sec some function, tan of tan root x, tan some function, sec square some function, d by dx of some function. So this is the last derivative, right? Last derivative first. Root some function. 1 upon 2 root some function, d by dx of some function. Rest of part as it is. Rest of part as it is. What is dx by dx? 1. So what will be the answer? 1 upon 2 root x, sec of tan of root x, tan of tan root x into sec square root x. This is the answer. Next question. Sin ax plus b upon cos cx plus d. Fifth one. Sin ax plus b upon cos cos Cx plus d. That is given procedure. If we observe first, second and third, observe that. Here only single variable x is there, x is there, x is there. Here x is there, here also x is there, here also x is there. But here 2 times x, and that is in form of division. Here also 2 times of x, maybe in product form. See, whenever it is composite form, then use composite form. Whenever it is in division form or product form, then use division rule, product rule. So here we are going to use division rule. See, differentiate with respect to x. So dy by dx is equal to d by dx of sin ax plus b over cos cx plus d. Now you all of you know the division rule for differentiation. Denominator quantity whole square. Denominator quantity whole square. Denominator quantity as it is. Derivative of numerator minus numerator as it is. Derivative of denominator quantity. D by dx of cos cx plus d. First of all, we are applying product division rule. Now, see the forms. See, here we can write directly in this way also. Cos square cx plus d in. So there is no need to make this division sign throughout. Because x by 2x plus y upon 3, that is 1 by 3 of 2x plus 0. Now first term as it is, cos of cx plus d as it is, sin some function, cos some function, d by dx of ax plus b. Then sin of ax plus b as it is, cos some function. So minus, already minus sign is there, so plus cos some function, sin some function, d by dx of some function, cx plus b, and this bracket is complete. Now that is equal to 1 upon cos square cx plus d. What is derivative of ax plus b is a linear form. A. So write first, last derivative first. A cos cx plus d cos ax plus b. Derivative of cx plus d, b. is only c. C sin ax plus b sin cx plus d. This is the answer. We can't simplify it because a and c is there. If a and c is not there, cos alpha, cos beta plus sin alpha, sin beta, that comes out cos alpha minus beta. But here it is a and c, so leave as it is. This is the answer. Next question. What is given? Cos x cube sin square x raised to 5. Cos x cube. Next, take y is equal to cos x cube sin square x raised to 5. See, cos x cube sin square x raised to 5. Question number 6. But in our case, it is third one. I am solving this one is third sum. Differentiate with respect to x. In previous form, division is there. So we are applying division rule. Here product form is there. So apply product rule. And therefore dy by dx is equal to d by dx of cos x cube sin square x raised to 5. So apply product. That is equal to first function as it is, derivative of second function plus second function as it is, derivative of first function. Okay, this is the product. Now, here it is. What is meaning of this one? Sin square x raised to 5 is sin x raised to 5 whole square. So some function square is given. Cos x cube, some function square. 2 times some function d by dx of some function. Plus, whenever cos is there, then please do not put any sign. Cos some function, so minus sign, so write first. Sin square x raised to 5. Cos some function, sin some function, d by dx of some function. Write to first 2 cos x cube sin x raised to 5 sin some function cos some function d by dx of some function. Write last derivative first. 3 some function a raised to n into some function raised to n minus 1 d by dx of some function into sin square x raised to 5 sin x cube. Now write last derivative first. 5x raised to 4 d by dx of some function raised to n, some function raised to n minus 1 d by dx of some function. Rest of part A will be 2 cos x cube sin x raised to 5 cos x raised to 5. Cos x raised to 5 minus 3x squared sin square x raised to 5 sin x cube also. Now that comes out 5 x raised to 4. Now see, cos x cube 2 sin theta cos theta sin 2x raised to 5. 2 sin theta cos theta sin 2 theta minus 3x squared sin square x raised to 5 sin x. This is the answer. Okay. What is the next one? Next one. This one is your number 2 root cot x square. Next one, 2 root cot x square. That is our y. Okay, this is our y. Differentiate with respect to x on the same line. So what we get? Dy by dx is equal to d by dx of 2 root cot x square. 2 is constant term, so take it outside. 2 d by dx of root cot x square. That is equal to 2. What is root some function? Yes. 1 upon 2 root some function d by dx of some function. 2 to cancel. 1 over root cot x square. cot sum function minus cosec square sum function d by dx of some function that is equal to minus 2x dx by dx into cosec square x square, last derivative right first, over root cot x square, that comes out minus 2 cosec square x square upon root cot x square. Yes, this is the answer. Yes. Next, see what is given? Prove that this function f is given by, this one is not differentiable at x is equal to 1. See, this one based on definition of differentiation. We know that, please see, here fx is equal to magnitude of x minus 1. We already seen in last lecture, fx is equal to magnitude of x minus is continuous everywhere. Here we are going to see that this function is continuous at 0 but not differentiable at 1. Sorry, this function is continuous at x is equal to 1 but not differentiable at x is equal to 2. Let us see that part. Now what is f dash x? That we know from the definition. Limit t tends to x, f of t minus f of x over t minus x. This is the differentiation of function f with respect to x at x. But we want f dash 1 because what we want to see here, prove that this function is not differentiable at x is equal to 1. So what is f dash 1? Limit t tends to 1 f of t minus f of 1 over t minus 1, and that is equal to limit t tends to 1 f of t is equal to f of x is equal to magnitude of x minus 1. So f of t is equal to magnitude of t minus 1. What is f of 1? Magnitude of 1 minus 1 over t minus 1. And that is equal to limit t tends to 1 magnitude of t minus 1 over t minus 1. So result number 1. F dash 1. What is f dash 1? Differentiation of function at x is equal to 1 is nothing but this limit. If this limit exists, then f is differentiable at x is equal to 2. But if we see that, if we show this limit not exists, then function is not differentiable at x is equal to 2. So let us calculate this limit. Now see, for this limit, modulus is that. So we need to take left and right hand limit. So start with right hand limit. Limit t tends to 1 plus magnitude of t minus 1 over t minus 1 is equal to limit t tends to 1 plus. Give the reason. T tends to 1 plus means what? Implies t greater than 1. So t minus 1 greater than 0. So magnitude of t minus 1 is equal to t minus 1. So here it is t minus 1 over t minus 1. And that is equal to limit t tends to 1 plus 1. Constant term, limit of constant is constant. Now right hand limit, left hand limit. T tends to 1 minus magnitude of t minus 1 over t minus 1. And that is equal to t tends to 1 minus, put the reason. T tends to 1 minus implies t less than 1. So magnitude of t minus 1 is equal to 1 minus t, or we can write minus of t minus 1 over t minus 1, one and same thing. That is equal to limit t tends to 1 minus minus 1, that is minus 1. Right hand limit exists, left hand limit exists, but they are not equal. So limit not exists. So what we are writing here? And therefore this right hand limit exists as well as left hand limit also exists, but they are not equal, and therefore limit not exist, and therefore limit t tends to 1, magnitude of t minus 1 upon t minus 1 does not exist, and therefore by 1 limit does not exist, therefore evidence 1 does not exist. See, in result number 1, that is equal to f dash 1. F dash 1 does not exist, so what? And therefore f is not differentiable at x is equal to 1. Okay. Next, we want integer part function. See, 0 less than x less than 3 is given. It is not differentiable at x is equal to 1 as well as x is equal to 2. I am going to show that it is not differentiable at x is equal to 1, and I am leaving for you x is equal to 2. Next, what is given? F of x is equal to what is the integer part function x 0 less than x less than 3. You can write directly also, but write in a step by step. What is f dash x? Limit t tends to x, f of t minus f of x, t tends to x over t minus x. Okay. Now we want to check it at t is not differentiable at x is equal to 1. So what will be the f dash 1? F dash 1 is equal to limit t tends to 1 f of t minus f of 1 over t minus 1 is equal to limit t tends to 1. This is integer part function t, integer part function 1 over t minus 1. That is equal to limit t tends to 1 integer part t minus 1 over t minus 1, because integer part of 1 is 1. So this is our f dash 1. Cell result number 1. Now prove that left hand limit, right hand limit not equal. T tends to 1 plus integer part t minus 1 over t minus 1. Limit t tends to 1 plus. Give the reason. T tends to 1 plus means t greater than 1. So here should be integer 2. And this implies integer part t is equal to 1. Okay? Fine. Because see, we know this result. And less than or equal to x less than n plus 1 implies integer part x is equal to n. For all n belongs to z. These two integers should be successive integers. Okay. So here 1 less than 2, definitely we need to add 2. So that integer part t is equal to 1. So what we get here? 1 minus 1 over t minus 1. That limit t tends to 1 plus 0 over t minus 1. And that limit is 0. Okay. Now right hand limit exists, but that is equal to 0. Now start left hand limit. Limit t tends to 1 minus integer part t minus 1 over t minus 1. Limit t tends to 1 minus, give the reason. T tends to 1 minus means t less than 1, so there should be integer 0. So what is integer part t? That is equal to 0. 0 minus 1 over t minus 1, that is equal to limit t tends to 1 minus 1 over t minus 1. This tends to minus infinity. If we take t is equal to 1, 1 over 0 minus infinity. minus in outside, so minus infinity. So this limit not exists and is not exists. So lateral limit exists, lateral limit not exists, and therefore limits are not equal. Therefore limit not exists. Yes or no? And therefore limit t tends to 1 integer for t minus 1 over t minus 1. This limit does not exist. And therefore by 1. By 1. F dash 1 does not exist. Clear? Yes. And therefore F is not differentiable at x is equal to 1. On same line you can see that this function is not differentiable at 2. The 2 then 2, 2, 2, 2, 2, 2, 2, 2. But here what you get? 2, 2. Here also you get 2. Up to this is 2. Then find out right hand and left hand limit. In that case, this limit not exists. Because t tends to 2 plus means 2 less than t less than 3. So it comes out 2. So here don't get 2 minus 1 over t minus 1. That is t minus 2. So that is 1 over t minus 2. And that limit not exists. Is it clear? So I am doing that part too. Next one. See. What is given? Derivative of implicit function. One thing. What mean by implicit function? See, x square plus y square is equal to, if I take r square, then it is not easy to make x and y as a head, because if we take y square is equal to r square minus h square, so y is equal to, you get plus or minus. So means f of some function is given of this form in relation form of x into y, then that function is known as implicit function. Here we want dy by dx or these two forms are given to us. What we need to do? We need to take direct differentiation. See how here x minus y is equal to y. Differentiate with respect to x. There is no need to take y as a head or any other variable as a head. Whatever maybe relation is given to us, differentiate directly. So d by dx of x minus y is equal to d by dx of y. Here difference is that, so give derivative to both one. D by dx of x minus d by dx of y is equal to 0. And this comes out 1. 1 minus d by dx is equal to 0. And therefore, d by dx is equal to 1. Clear? Next what we want? Y plus sin y is equal to cos x. Y plus sin y is equal to cos x. Second part is given to us. See. Differentiate with respect to x. Differentiate with respect to x. So what we get? D by dx of y plus sin y is equal to d by dx of cos x. In the previous some difference is given. Here addition is given. Due to what term? D by dx of y, d by dx of sin y, cos of some function minus sin of some function, d by dx of some function. Here what we get? Dy by dx plus sine of some function, cos of some function, d by dx of some function, dy by dx. Here it comes out minus sine because dx by dx is 1. So, take dy by dx is common, is equal to minus sin x. So what we get? Dy by dx is equal to minus sin x over 1 plus cos y. Very easy. Here. Next. Here. So this thing we already seen. Find out derivative of sine inverse, cos inverse, tan inverse, cot inverse, likewise. And we notate this formula of this form. Sine inverse something is equal to minus 1 upon under 1 minus some function square d by dx of some function and magnitude of some function less than 1. Likewise, we already seen all the 6 trigonometric forms, inverse trigonometric forms in last lecture. Let us see. Find dy by dx. These all are implicit functions. Now see, very simple forms are there. So I would like to leave first, second, third and fourth for you. I would like to solve fifth and sixth. Just take differentiation on both sides. Nothing else. Please. Fifth one. X square plus xy plus y square is equal to 100. That is given to us. Differentiate with respect to x. So d by dx of x square plus xy plus y square is equal to d by dx of 100. Now addition is given. Differentiate term by term. D by dx of x square, d by dx of xy, d by dx of y square, and right hand side is 0 because constant term is there. D by dx of some function square, 2 times some function, d by dx of some function. Here product is given, so apply product rule. First one is it is derivative of second one. Second one is it is derivative of first one plus some function square 2 times some function d by dx of some function is equal to 0. Yes. This one is 1, this one is 1. So what we get? 2x plus 1. First bracket. From here x divided by dx, here divided by dx. So take dy by dx common, x plus 2y into dy by dx is equal to 0. So what we get? And therefore 2x plus y is equal to minus x plus 2y into dy by dx. So what is dy by dx? And therefore dy by dx is equal to minus of 2x plus y over x plus 2y. Is it clear? Yes. Next, example number 6 is given that what is relation is given to us? X cube plus x square y plus xy square plus y cube is equal to 81. This relation is given. See, in remaining whole sums you have to take direct differentiation on both sides. Here on right hand side cos y is given. Cos of some function minus sine of some function d by dx of some function. Only we have to apply that relation. Now let us see this one. Differentiate with respect to x on both sides. See, in board exam in written paper we need to solve only one question, not we are going to solve more than 2 or 3 questions. Either it is of 2 marks or 3 marks or 4 marks, doesn't matter. We have to write step by step. If differentiation is there, then apply working rule of differentiation as well as standard forms. See, so first of all take d by dx on both sides. X cube plus x square y plus xy square plus y cube is equal to d by dx of 81. Here also addition is given to every term. So give it to every term. So d by dx of x cube, d by dx of x square y plus d by dx of xy square plus d by dx of y cube on that hand side constant, so derivative is 0. Now apply rules one by one. Some function raised to n. So 3 times some function raised to n minus 1 d by dx of some function. Here product is there, so apply product rule. X square as it is d by dx of second function as it is d by dx of first function plus first function as it is d by dx of second function as it is d by dx of first function, that is dx by x. Plus some function raised to n. 3 times some function raised to n minus 1 into d by dx of some function is equal to 0. Okay? Yes. So what we get here? Here we get 3x squared. Here dy by dx. Here x squared. So 2x is some function square. 2 times some function dy by dx of some function. Y as it is. Now x as it is some function square to y equal to d by dx of some function. This comes out y square and this comes out 3y square divided by dx is equal to 0. Yes or no? Now collect terms not considering dy by dx. Here 3x square, here 2xy, and here we get y square. Put it into one bracket. Plus take dy by dx common from this one, and this one. What we get from there? X square. Here we get 2xy. Here we get 3y square into dy by dx to 0. Very simple. Now from this one we can write directly dy by dx here also, but write one constant. 3x square 2xy plus y square minus of x square, this one as it is, 2xy plus 3y square into dy by dx. What will be the dy by dx in this case? And therefore dy by dx is equal to minus of x square plus 2xy plus 3y square. This goes in denominator quantity, remember as it is 3x square plus 2xy plus y square. This is answer. Here. Now see. Now all of you are able to solve the remaining 4 questions directly to differentiate it. So this 1 to 4 sums are for compound. Okay. Next one. See. Here it is given that find dy by dx. Whenever sin square x plus cos xy equal to constant is given. Sin square here, sin square y plus cos xy xy is equal to constant is given. No problem, differentiate it with respect to x. Differentiate with respect to x. What will I get? D by dx of sine square y plus cos xy d by dx of constant term. So what we get here? Now see here. Sum is given to give what differentiation to what term? D by dx of sine square y plus d by dx of cos xy. On right hand side k it is 0. Some function square 2 times some function d by dx of some function cos of some function minus sine of some function d by dx of some function is equal to 0. Now see, therefore 2 sine y, sine some function, cos some function, d by dx of some function, okay, minus sine xy. Here product is given, xy. So apply product. X into dy by dx plus y into d by dx of x is equal to 0. Here 2 sine theta cos theta, that is sine 2y dy by dx is equal to sine xy into x divided by dx. So minus x sine xy into dy by dx minus this one is 1 sine xy into y means like y sine xy is equal to 0. So from very first two terms take dy by dx common. Sine 2y minus x sine xy into dy by dx, take it on right hand side, y sine xy. Now make a head. What is dy by dx? And therefore dy by dx is equal to y sine xy over this one. Sine 2y minus x sine xy. Here, yes, this is the answer. Next, what is given to us? Sine square x plus cos square y is equal to 1. Sine square x plus cos square y is equal to 1. Differentiate with respect to x on both sides. So d by dx of sine square x plus d by dx of cos square y is equal to d by dx of 1. Sorry. Now differentiate to term by term, and therefore d by dx of sine square x plus d by dx of cos square y is equal to 0. What a derivative of sine something square, some square. D by dx of some function into d by dx of some function, that is equal to plus 2 some function d by dx of some function is equal to 0. Therefore 2 sin x d by dx of sin some function, cos some function d by dx of some function, cos some function, minus 2 cos y sin some function into d by dx of some function is equal to 0. So, what can you say about this one? Is nothing but sin 2x minus sin 2y into dy by dx, and same time take it on right hand side also. So what is dy by dx? So dy by dx is equal to minus of sin 2x upon sin 2y. Yes or no? Yes. Next one, it is given here inverse trigonometric form. Y is equal to sin inverse 2x upon 1 plus x square. What is given? Y is equal to sin inverse 2x upon 1 plus x square. Dear friends, these are the inverse trigonometric forms. Please learn all the standard forms of inverse trigonometric form. In next lecture, we are going to see the derivative of inverse trigonometric form. Clear? Yes. Thank you, dear friends.